So first up, we have to identify if this problem reacts. And it does if we check the activity series. Aluminum is above copper, so it's all good. All right. What's going to happen on the product side? What are we going to end up with? James?
AL and O3, like 3 of them, and then copper or something.
Okay. All right, so we're gonna end up with something like this, but we have to figure out the charges, right? All right, so what's the charge for aluminum when it comes over here? Yeah, +3. What's the charge for each nitrate? -1, good, okay. What about for the copper? What's the copper's charge over here? All right, +2. All right, nitrates -1. And then let's talk oxidation number. What's the oxidation number or the charge of aluminum right now?
0.
Yeah, 0. And then copper? 0. Okay, good. So we just need to balance this and then we should be good. All right, so now that's balanced. Now we have to balance the whole thing. Where do we need some numbers? Okay, cool. Yeah, exactly. So we see here there's a 2 and a 3, least common multiple for them, right? So we're going to put a 3 in front of this. So then we'll get 6 nitrates. Put a 2 in front of this. So we get 6 nitrates. All right. Now the aluminum, 2, and then the copper's 3, and then 3. Okay, we're good with that, right? Great. All right, next thing we need to do is the redox stuff. So let's identify what lost electrons. Okay, so let's check it out. Aluminum was 0. It went from 0 to +3. Yeah, it lost electrons. So if you lose electrons, loss of electrons, what is it? Oxidized. Good. So this would be oxidized. All right. And then if you gain electrons, then it's going to be reduced. So what gained electrons? Copper. Yeah, it went from +2, it gained 2 to become neutral here. So it gained electrons. It's going to be reduced. Okay. So if this was oxidized, what's this? The reducing agent. Good. And if this was reduced, what is this? Oxidizing agent. All right, great. Everybody okay so far? All right, half equations for this. So now we need to figure out the electrons, where the electrons are moving. So I'm just going to pick aluminum just because it came first. So I'll have aluminum on the right. I'll have aluminum +3 on the right over here. And what happened to it again? It lost electrons, right? So if it lost electrons, what side are the electrons going to be on? The left or the right? Yeah, it's going to be on the right. Good. So it's going to be on the right. This is where our electrons are going to be. We also have to kind of keep it balanced. So we have two aluminums here, okay? So in total, how many electrons did aluminum lose?
6.
Yeah, 6. Each one lost 3, right? So 6 was the total amount of electrons lost, because for each of the aluminums it was 3, and then there's 2 of them. All right. All right. Now let's do the copper. Copper started out as +2, and then it went to it was reduced, so it was brought to 0. And how many do we have of them? We have 3. And we have 3 here. Okay. So copper went from +2 to 0. Did it gain or lose electrons? Gained electrons. Yeah, how many did it gain? Each one gained 2, and there was 3 of them here. So the total is +6 electrons. Yeah, exactly. All right. And so you have the same number of electrons on the reactant side as you do for the product side. If you bring these two things together, that would be kind of like the redox reaction, right? The only thing that's left out is the nitrates, because they're not really involved with redox.